Hello everyone, this is a video lecture for College Algebra Math 1314 section 9.3. We're doing matrix operations. Anyways, so we're going to do number one. Number one, it says solve for x, y, and z. Given this, I guess, two matrices equal to one another. This is so easy, I almost didn't put it on here. X equals 9. Yeah, you just did that. Isn't that awesome? Here's another one. Z equals 13. So cool. Here's another one. 3y is equal to 6. Oops. I wonder what y is equal to. I wonder what y is equal to. Math jokes. Okay, and then finally, we got 4 is equal to 4. True. So there's nothing else to put there. Yay, we solved for everything. I'm hoping you can do that one. The next one's a little bit bigger. It says we have an A and a B, and they want you to add, subtract, multiply, divide, and then even solve this equation thing. This is not hard. If you put a big old plus sign between them, what you have is this is a 3 by 2 and a 3 by 2, and a 3 by 2 plus a 3 by 2 is going to make a 3 by 2. And so I'm going to go 1 plus negative 4 is a negative 3. Negative 3 plus a negative 2. Two negatives will combine together here to make a negative 5. Negative 7 plus 4 is going to be a negative 3 again. I got a negative 5 and a 1 makes a negative 4. Negative 9 plus 0 is negative 9. And then negative 7 plus the 3 is a negative 4. There you go. There's your answer. And so you actually have to type in the matrix, click a special button to get the matrix to pop up on your math homework program, etc. But that's it. There's your answer. Now just repeat with a minus sign at times and all that other stuff. Well, that's fine, but Desmos. And Desmos will do all this much better and faster. Matrix calculator, like we've seen before, and I'm going to have to put in two matrices. So this is going to be a 3 by 2 and then another 3 by 2. You'll just see me go ahead and put that in. So real quick. In a way, I want to prove something to you about how it's going to be easy. Click new matrix again. Again, this is just going to be a 3 by 2. And then A plus B. Is that what we got earlier? Negative 3, negative 4, negative 9, that kind of thing? Looks like it. What if they wanted A minus B? What about negative 2 times A? I'm not even writing these down. You can just look at it. What was that last one? Second to last one. 5 and a negative 3. 5A minus 3B. I mean, it's so fast. And it's very accurate. Please use Desmos. All right, for the last one, it's a little more involved. They say we need to solve for x. So I need to solve for x with these equations. So minus a on both sides. 2x is equal to b minus a. You can divide by 2, but what I'd rather you do is say multiply by a half. I know that's kind of a little weird to say, but in matrix land, you can't divide necessarily. You can do a scalar division. It's called a scalar when it's in the front like that. But division with two matrices just does not work. So it's better to do that. Well, this is my equation. I know it looks like just a big old dot. That's supposed to be a time sign, okay? So 1/2 times b minus a. And so 1/2 times b minus a. And yes, they look like they could have fractions. That is totally possible. So yeah, definitely there could be fractions, and definitely that is okay. That's just part of it. Okay. Let's keep moving. So this next one here says we got these two matrices and they want to multiply them. Notice AB, A times B is what they're trying to say. And we're going to just use the Desmos calculator, matrix calculator for this as well. So I'm going to start over. New matrix. And notice the first one here is a 1 by 4. So it's a 1 by 4. 5, 6, 7, 8. And then my B matrix is a 4 by 1. And that is the 3, 4, 5, 6. And they want A times B. Well, you know what's so weird? We got a single number. 122. But notice that it's still a matrix. It's a 1 by 1 matrix. Very strange, right? So let's talk about this for a second. When you're multiplying two matrices, what you got to do is take their sizes into account. So A times B, what you actually have here is a 4 by 1, and this here is a 1 by 4. The only way that matrix multiplication will work is if you have the inside numbers the same, and they are the same, so this will work. The result is on the outside. In this case, it's a 4 by 4 result. Oops. You know what? I messed something up here. This is a 1 by 4, and this is a 4 by 1. I'm doing the wrong problem over here. But I'll leave it up, because this is fine. Kind of. This is B times A. I'm so sorry. It happens. It happens. Okay, A times B got a 1 by 4 and a 4 by 1. Still applies, though, doesn't it? See how the inside numbers are the same? And so the result that we got this last time was a 1 by 1 result. Now, as you can see, though, if we do B times A, again, they're going to be the same, and we result in a 4 by 4, which is going to be kind of weird. Do you have to know any of this to make it actually work? Not really, because you could just type B times A, and boop, there's your 4 by 4 matrix. So if it doesn't work for some reason, then it would tell you. It would say, no, it doesn't work. So it is important to see this, though, to see this similarity, this same number on the inside kind of thing. That's good. But in the end, Desmos will do it all for you, which is nice. Anyways, so there you go. Now, this one's also asking for A minus B. And so A minus B, what does it say? Cannot do it. And if you can see it says different dimensions, you can't subtract them. We were able to subtract the previous ones because they were the same size, but not here because they're two different sizes. So if your math homework program says find it, and Desmos says you can't do it, then say you can't do it. You go and tell the math homework program that you can't do it. Kind of like no solution, but rather I would say just doesn't work. The operation doesn't work. Okay, so that's what I would say right here. Doesn't work. All right, this is actually the last problem that I have here, and I'm combining two different problems together. What they're wanting to do here is multiply A times B and then graph what they should be, given that these would be some points here. This is X and Y coordinate points. So in a way, what we already have is on a grid, on a graph here, we got 0, 0, 6, 0, which is somewhere over there, 6, 1, 1, 1, 1, 8, really high, and then 0, 8. And if you connect the dots, you have an L. You have an L. So what they're doing with this L here is multiplying it by the A. On other problems, they want to shift it around. They'll say, like, hey, move this L to the left by 5 and move it down by 3. And if you had to do that, you would just simply take all your X numbers and minus 5 from these and minus 3 from those. Or if this says move it up, you would add. Move it to the right, you would add. Anyways, we're not going to do that one directly, but you can see that it's not too bad. You just simply take these numbers and add and subtract whatever you need to do. I want to multiply these two. And so I'm going to multiply them in Desmos, of course. I don't have to do this because I already know how the answers are going to look. But I just wanted to prove to you yet again that you can do this, all of it, in Desmos matrix calculator. Now notice this size here is it's a lot different. It's a 2 by 6, and so it's a 2 by 6. Just make sure that you can fit all those numbers. That's really the main point here. And don't mistype anything. Okay, so we're doing A times B. And there's your answers. Like, that's it. I actually do want to write these down so that I can show you what the new graph is going to be, because they say graph it. So we got the 1s and 8s in the top, and then we got the 6s in the bottom. It looks, if you go back and forth, it looks like they swap places and that the bottom is negative. They swap places in the bottom. So let me write that up here. They swap places. Bottom is negative. There you go. So when I graph this one now, actually, you know what? I'm going to graph it on top of the same one right here. And I'm going to use a red. So 0, 0, same thing. 0, negative 6. So 0, and then negative 6 is going to be down there. 1, negative 6. I got 1, negative 1. 8, 1. It's kind of way out here. That was 6, so this has got to be 8. It's a little bit further. Then 8, 0. And if you connect the dots this time, you get an L again. Let me make that a little bit better there. There you go. You get an L again. But what has happened? They're going to ask, they're going to say, what happened to this thing? Well, notice that it rotated down. So this is my pivot, essentially, and this swept in at 90 degrees. So it rotated 90 degrees, essentially. Okay, so yeah, you would say, what's your answer? It rotated. All right, awesome. That's it. That's all I got for this section. So, thank you very much, and have a great day.